Hi guys, so I'll be doing the problems from PP 1.2 where we did simplifying rational expressions. Okay, so let's do the first problem. Let's see. I'm going to rewrite the denominator. I mean, some of you guys are good at factoring when it's not in standard form, but I kind of like my math to be a little bit more organized, but you're going to end up with the same answer. Okay, so I put it in standard form with the decreasing exponents. And then let's try to factor out a GCF. So the numerator, we have a 12 and an M for our common denominator. And I think we determined that was a 4. And then negative 18 n to the second. And I think that is n to the second. Okay, 288 divided by 18. It goes in 16 times. Okay, so we have a negative 16. And what you realize, talked about this in class, is that that is a difference of squares. So it factors as just like that. So you're going to have one factor plus and minus on the second terms, and take the square root, n, and 4, and 4. Okay, once we do that, we could start canceling things because these are all in factored form. So 12 is a factor, n is a factor, n minus 1 with the parentheses around it because that entire binomial is a factor. Okay, so I could simplify the n minus 4 and the n minus 4. Okay, and then I could simplify the n to the 1. That'll get simplified, and 12 and 18 are both divisible by, I believe, 6. So you have a 6. Oh, I'm sorry, a 2 in the numerator. Let's go ahead and do 2 and 6. No, 3, I'm sorry. And a negative 3 and an n plus. Oh, goodness, I keep on getting all of these right. I mean, wrong. N plus 4. And there you go. Good job. Next, we have, take a look. Let's take out the GCF of 2x. We have a 2 common between the terms and an x common. So we have an x minus 1. We have a 4x squared. X squared minus 1. And when you look in the denominator, right here, x squared minus 1, that is a difference of squares. So many difference of squares. It factors in that way. And then I could start simplifying. Here we have a 1 and a 2. And that's going to be a 1 and an x. And that simplifies as 1 and 1. So I end up with a 1 over 2x times x plus 1. There we go. Good job. Number 3. Number 3. Okay, so there is a trinomial in the numerator. Do stuff on this calculator so it doesn't close out. And so we have to factor that numerator. And I'm going to put that denominator in standard form. And once again, some of you guys are okay with factoring, okay, in the form that it's in. That sign tells us that these two are going to be different. The factors of a squared is a and a. And then factors of 20, where we find the difference, and they're going to equal a plus 1. So that would be 5 and 4. Okay? So we have an a plus 5 and an a minus 4. Let's go ahead and see what we have for common factors here. I have a negative 9. I could take out a negative 9. And an a minus, is it 36 divided by 9? 4. Okay, I just took out a negative 9a from both of these, if you want to check it that way. And then we could start simplifying, because everything in the numerator and everything in the denominator is in its factored form. Take that out, that out. And so you end up with a plus 5 and a negative 9a in the denominator. Good job, guys. Okay, next, number 4. We've got a little bit more going on this one. We know that that numerator could be factored. That sign tells us that these two are going to be different. The factors of x squared are x. Factors of 24. When you subtract it from each other, you get a positive 2. It's 6 and 4. 6 times 4, right? 6 times 4, 24. So 6 goes here and a 4. Because it'll be plus 6x minus 4. So that'll be a plus 2x. The O and the I. In this denominator right here, I'm going to take out an x squared. So I get an x plus 6. Times this numerator right here. I can factor out an x plus 3. This denominator, I'm going to go ahead and factor. That sign right there tells us that those two last terms are going to be different. Factors of x are going to be x and x. Factors of 12, when we find the difference, when we get the difference, equals negative 1. We couldn't do 6 and 2. Nope. 4 and 3. 4 is going to go here, and 3 is going to go here. And so we have two fractions. And, you know, the way that you do fractions is you just make them into 1. You multiply the numerator across. You multiply the denominator. And when you do that, you have multiplication in between all of these factors. So that means that we can cancel out factors in the numerator and in the denominator. You can only do that when they are in the factored form. You can't do it when there's an addition or a subtraction. And you're thinking, hey, there's an addition here and a subtraction there, but it's contained inside of a parenthesis. So that tells us that you have to take that entire binomial as a factor. Okay, so go ahead and let's start simplifying. So we have an x. We have an x in the denominator. X minus 4 crosses out with x minus 4. X plus 6, x plus 6, x plus 3, x plus 3. We just have this one x, and all of these turned into 1. So we have 1 over x, and that is our final answer. Good job, guys. Okay. Number 5. Let's take a look. Okay, so that looks like a trinomial. There is no GCF in between the three terms. Take this. And so I have to factor it. That tells us that The two signs are going to be different. And you can use the AC method on this. If you don't know how to use the AC method and you just know how to do the trial and error, that's fine. Okay, but the AC method would be take 11W minus 3, multiply these two, 4 times 3, which is negative 12. Okay, and then figure out the factors of negative 12 this middle term. So that'll be a negative 12 and a positive 1. And you would rewrite this. Let me go ahead and do it a little bit above because I'm going to need room. Okay, you would rewrite it. And that would be a minus 12 and a plus 1. Split the W's. But you have to still divide it because since we multiplied, we have to divide both of these by 4 and then reduce. So you end up with a W minus 3. You can't reduce 1 over 4, but you have to take that denominator and swing it to the front. So 4W plus 1. Okay, so we have a 4W and a 1 and a W minus 3, and I can check. 4 times negative 3 is negative 12, and then we add 1 to it, the O and the I, so that works out, and it makes it negative 11. Okay, this is a difference of squares. That is a perfect square. That's made up of 4W times 4W, made up of 1 times 1. So it's going to be a 4W plus 1 and a 4W minus 1. Okay. Let's not do that. Okay. And then I'm just going to erase that. You'll see it on my video, the AC method. Let's go ahead and factor out the greatest common factor between the two. So we have a 4W minus 1. And rewrite this as negative W squared and plus 9. And you can factor that as a difference of squares using the same rule. Okay, and that's going to be, I'm going to take out a negative 1, so that's going to be y squared minus 9. Negative 1, that factors as a plus 3 minus 3. Or if you want to just straight factor that, then that just becomes a 3 plus W and a 3 minus W. Either way, you have a choice. So negative 1 times y plus 3, y minus 3. Okay, we can make it into one fraction and multiply. Okay, let's see if anything cancels out. That cancels out. That cancels out. Remember, these turn into 1. Okay. Oh, cancels out right there. So we end up with a 2 over negative 1 times W plus 3. I can take that and then put it to the top. So I end up with a negative 2 and W plus 3. There we go. Good job, guys. Okay, number 6. We have a division, and division is all division is multiplying the reciprocal. That's all that is. Okay, so it looks like I have a difference of squares here. C plus 1, C minus 1. That's also a difference of squares. So C squared plus 1, C squared minus 1 times, I'm just going to take the reciprocal of this, C squared plus 1 and C plus 1. Look at this right here. We can also factor that out. That's a difference of squares. So we're going to end up with C plus 1, C minus 1, c squared plus 1, c plus 1, c minus 1. And then we're going to multiply across. I like to put these in parentheses. So it knows that it's its own entity. Those are binomial factors. And then I'm going to start canceling. Cancel that with that factor. I could cancel this with this factor. And I could cancel this factor with that factor. So what I have left over is 1 over c plus 1. Good job, guys. Okay, number 7. Take a look. Okay, it's another division. Yeah, calculate. Okay, let's go ahead and look at the first term. This numerator right here, what's common is an m. Take that m out. Let's see. We can factor this trinomial. That sign tells us what it is. The factors of 2m squared is 2m and 1m. The factors of 15 are 1 and 15 and 3 and 5. Let's see. I'm going to try 5 and 3. 5 and 3. Yeah, that works. Times, take the reciprocal. And also you see that that's a difference of squares. And then that numerator now becomes a denominator, and I could take a 4m out, and I get 2m plus 3. Okay, let's make it into one big fraction. And since the numerator and the denominator is in completely factored forms, we can start simplifying. M and m, 2m and 2m. And I like to just put a 1 just to indicate m minus 5, m minus 5. So I end up with a m plus 5 in the numerator. I have a 4 and a 2m plus 3. There you go, guys. That's it. Good job. Moving on, we have addition and subtraction. Okay, so now one of the things that we may have to go over, I'm going to go over it, is something called the least common multiple. Least common multiple. And you guys know the greatest common factor. Just looking at like to the 4th minus m to the 2nd plus 4m, and then taking out the greatest common factor. Remember, something that gets multiplied, and you have to find the greatest amount of it. Okay, the greatest amount is always confusing because it's actually the smallest amount that you see it in. Okay, so like I see a 4 and a 2. The greatest would be 4. Okay, because this is 2 to the 2nd. But you take out the least amount. And that's always confusing for me. You take out the smaller of the two. Okay, and you take the smallest out of the m's. M to the 1. And so you end up with an m cubed minus m plus 2. Now, the least common multiple is something that we use when we find common denominators. So if you have 1 over 5, okay, plus 1 over 25, the common denominator of 5 and 25 is 25, right? So we have to change both of these into 25 over 25, And so in order to do that, we have to multiply this by 5 and 5. And so that becomes 5 and 1. And then we can combine the two. So it's 5 plus 1 over 25. But if you actually think of this as 5 to the second, and this is 5 to the 1, and I compare the two denominators, 5 to the 1 and 5 to the second, what you're taking out is the greatest number of times that that factor appears in the denominator. And the greatest number of times that it appears is twice. That the factor 5 appears is twice. Okay, you can do that with all of them. So for example, if you had something like 1 over, let's say, 2a to the second b plus 1 over 4 times 3 and a to the and b to the second. And if I'm comparing these and I look at the factors, 2 is a factor. Let's go ahead and write this down as, and I'm going to write it like this. It's 2 to the second. And this looks like this. So if I look at all the factors that are available, all the factors that are available is 2. And then there's a factor 3. And then there's a factor a. And there's a factor b. Okay, and if I tag along, if I put a c here, I also see a factor c. And I don't mean what they have in common. I just mean every single factor in the denominator. Now, to find the denominator, common denominator of this, you have to find the times that appears the most. Okay, so you look here, and 2 to the factor 2 appears here once, and the factor appears twice. So the greatest number of times it appears is twice. 3, here 0, here, let me use my mouse, here 0, here 1. The greatest number of times it appears is once. A, twice here, 3 times here, 3. B, once here, and twice there, so 2. C, once here and none here, once. That becomes your common denominator. And why? Because you can multiply to make a denominator more, to have it look like this denominator here, but you can't take away. You can't take it away. Okay, so after we had that little intro into these problems about the least common multiple, let's take a look at these two denominators. So we have a 2 times 3 times a. Those are all the factors of 6a. We have a 2 to the second, a to the second. Okay, now let's go ahead and figure out our denominator, the least common multiple. So for the first factor 2, the greatest number of times that it appears is twice. Okay, it appears here once, it appears here once, it appears here twice. For the factor 3, it appears once here. It doesn't appear any on the second fraction, but we have to take the greatest number of times. A once, a twice, so the greatest number of times that appears is twice. So we have, I'm going to go kind of skip the step in your class, and then I'm going to include the step, okay? As kids were kind of getting confused. And then so I take a look at this denominator compared to this denominator, okay? What is missing? How does this denominator become that denominator? And the way that we do that is to multiply this by 1, 2. We have a 3 already, and 1a. So what we do to the bottom of the fraction, we have to do to the top. Okay, so that numerator is going to be 2a. Okay, now let's compare this denominator with that denominator. What's missing? We have 2 2's, but we have a 3 missing. We have 2a, so we just have a 3 missing. So I'm going to multiply the bottom, the denominator, and the numerator by 3. So 3 times 3 is 9. Now I can go ahead and combine. So I have 2a minus 9, and I have 2 times 2 is 4, times 3 is 12a squared. That's my final answer. Good job, guys. Okay, let's take a look at number 9. 9, first of all, I'm going to put a 1 in that denominator. And then if I compare the two denominators of 1, I don't want to do this because some kids will get confused. I'll do it with a different 1 and x minus 3. And x minus 3 in itself is a factor, guys. That's a binomial factor. Okay? If I compare that, it's going to be x minus 3. Okay? Notice that factors have multiplication. Between x and 3, there is a subtraction. So you have to treat that entire binomial, 2 terms, as a factor. Okay? If it was 3x, then 3 would be a factor and x would be a factor. Okay? So what's missing in this denominator compared to that denominator is x minus 3. So I'm going to multiply the denominator and the numerator by x minus 3. So that's going to be a 2 times x minus 3. Okay. What's missing compared to x minus 3 and x minus nothing? So I'm going to take that, and I like to put a parentheses around that, especially when there is a negative right there. You see that? Negative. Okay. Because what usually happens is that kids forget to put a parentheses around it. Okay, let's go ahead and combine. So we end up with a 2 x minus 3 minus x plus 1. And then we get an x minus 3 in the denominator. Now remember I told you to put a parentheses around that x plus 1 right here. Okay, and the reason is that we have to distribute that negative through. And if I do that, it'll remind me that there's a 1, negative 1, and I can distribute that. So let's go ahead and distribute. So I end up with an x minus 7 over x minus 3. And that's my final answer. Good job, guys. Okay, let's take a look at number 10. Before we actually figure out the common denominator, we have to factor. Okay, so I have a 3p plus 4, and I like to put parentheses around that. And I could take out a 2 if I wanted. Factor out a 2. And so that's 32, 1, 16. And then we have a p squared minus 16. That's a difference of squares. So we have that going on. Okay. Notice that over here in the numerator and in the denominator, there's nothing to factor. And that would be the only reason that I would factor out the 2 from the numerator to see if I can simplify something in the numerator versus the denominator before I actually try to find my common denominator between these 2 terms. Okay. Let's go ahead and try to find a denominator. Remember, these parentheses, indicate that these are factors, guys. So the denominator, the common denominator, okay, is p plus 4 appears once and once. That's the greatest number of times. And p minus 4 appears once. And none there, but it's the greatest number of times. So we have a plus and a p plus 4 and a p minus 4. Okay? How do I get that denominator to look like that denominator? What do I need to multiply? Well, I need to multiply p minus 4. So what I do to the top, I have to do to the bottom. So I move with a 3 times p minus 4. Okay, and then this denominator and that denominator, the common denominator, look exactly alike. So I'm just going to leave that as 2 p plus 16. And you can distribute through because that's what eventually you're going to do. Okay, whoops. Equals, let's go ahead and distribute. So we have a 3p minus 12. And I'm going to combine the fractions. 2p plus 32. So I end up with a p, with a p and then a minus, is it a 20? Oh, I'm sorry, it's 5p. Not the same thing, wrong. In class, p plus 4, p minus 4. And then I can factor out a 5 in that numerator. So I get p minus 4, p plus 4, p minus 4. And here I can simplify that p minus 4 and p minus 4. So I get 5 over p plus 4. How did they end up with? Oh, it's a plus. Ah, I made it. Oh, I caught you there. Almost somebody got. Yeah, this is supposed to be a plus, guys. Yeah, I'm tired. Sorry about that. So what simplifies is p plus 4. So I have 5 over p minus 4. And that's my final answer. Okay? Good job. So number 11, okay, I see that we have a trinomial here. In the numerator, trinomial here, we're going to factor. That sign right there tells us that these are going to be different. Split the ends. 18, factors of 18. 1 and 18, 2 and 9. When you subtract them from each other, you have to get that middle term, positive 7. So I know that 9 goes there and 2 goes there. Let's go ahead and factor the denominator. That sign right there on that 6 tells us that these two signs of the second term of that factor is going to be the same. The negative tells us that they're both negative. So n, and that we have a 3 and a 2. 3 plus 2 is going to be, yeah. Okay, let's see. And then we have a 1 over n minus 3. Before we continue, and I kind of messed up last time, and I have to redo this number 11, is that you can simplify, guys. Why not? Simplify that. Okay, so you have n plus 9 and n minus 3. And look what we have, guys. We already have a common denominator. Okay, we didn't need to do anything further. Okay, so we have an n plus 9 minus 1 and an n minus 3. So we end up with an n plus 8 over n minus 3. And that's the final answer. Okay, good job, guys. Okay, next. Okay, the denominators. There's no factors. I'm going to put a parentheses around here. This one and this one. Okay, there's no common factor, so we just have to take y minus 7 once and y minus 4 once. So that's going to be the common factor. There's nothing in common between those denominators. So each binomial is a factor. Okay, and this tells us that what's missing from these two denominators. Now, how do we make that y minus 7? Well, what's missing is y minus 4. So I'm going to multiply y minus 4 over y minus 4. So I end up with a 2 times y minus 4. Now, what's missing from these two denominators is the y minus 7. I'm going to multiply that by y minus 7, that by y minus 7. So we get y minus 7. And I don't have to put it in parentheses, that addition. I don't have to distribute. Okay, in front, this addition is going to make things a little bit. So I'm going to just go ahead and distribute. Plus y minus 7. And we have a y minus 7 and a y minus 4. And so we have 3y minus 15. And then we have a y minus 7 and y minus 4. Now, if I take a 3 from that numerator out, I'm going to get y minus 5. That can't simplify with anything in the denominator, so I know that that is my final answer. Okay? Good job. Number 13. I feel like I need to factor this. This is r plus 3, r minus 3, and we have a r plus, let's see, what is that? R plus 5 and r plus 3, okay? So if you look at the two denominators, what is our common denominator? First of all, the factor r plus 3. It appears once on both. Okay. Next, r minus 3 appears once, and then r plus 5 appears once. So r plus 3, r minus 3, and r plus 5. Okay, what's missing when you compare the two from here and here are the r plus 5 factor is missing. So it's going to be r plus 5, and then you're going to multiply the denominator by r plus 5. Notice that the denominator looks exactly the same now. So we have r times r plus 5. What's missing? R plus 5 is there, r minus there is there. Let's go ahead and put it in a different color. That and that. Okay. So what's missing is the r minus 3. Okay. So r minus 3, multiply that, and r minus 3. 1 times r minus 3, r minus 3. Remember, I put it in the parentheses because that negative or that minus in front is going to be tricky. Okay, so let's go ahead and combine it into 1, and at the same time I am going to distribute that r and distribute this negative 1. And then I get r squared plus 4r plus 3 over r plus 3, r minus 3, and r plus 5. Now, if I look at that numerator, that's factorable, guys. R plus 3, r plus 1. R plus 3, r minus 3, r plus 5 in the denominator. Okay, can we simplify? Yeah, we sure can. R plus 3 could be simplified. Okay, so this ends up becoming r plus 1 over r plus 5 and r minus 3. And I'm just going to write it like that. I like to put the pluses in the front. Good job, guys. Next, we have a compound fraction. One of the ways that I didn't show how to solve a compound fraction, which is kind of like a trick, but you know, no, I don't want to really show it. I'm going to write it horizontally. So 4 over 1 minus 1 over k, and remember that has to be done together. First, 8k minus 2 over k squared. Okay, so the common denominator of that is going to be k. So to get that, I'm going to multiply k on top and k on bottom. So I end up with a 4k minus 1 divided by the denominator of this is going to be k squared. So I'm going to multiply that by k and numerator and denominator by k to get that k squared in the denominator. So 8k minus 2. Okay, keep, change, flip. Take the reciprocal and multiply it. Now we can make that one big fraction. Okay, 4k minus 1 times k squared. Clean it up a little bit. And then we could take a 2 out of here. So I'll end up with a 4k minus 1. So clean up the factors. So we have a 2k and a 4k minus 1. So you end up with a, we need to simplify. So you end up with a k, and we can we can cancel out that 4k minus 1. Okay, let me actually do this. So that's going to turn into k. That k will be gone, and 4k minus 1, 4k minus 1. So I have a k. Is it just k over 2? Yeah. I'm just going to get rid of that. Good job, guys. Next, let's go ahead and write that horizontally. 3 over 1 plus v over 2 divided by v over 4. Oh, horizontally. I'm sorry. That you do that first, divided by v over 4 minus 9 over v. Okay? The common denominator of the first two is 2. So to get the 2 here, we're going to multiply top and bottom by 2. So that's going to be 2 times 3 is 6 plus v divided by the common denominator of 4 and v is 4v. So I'm going to multiply top and bottom of this by v over v. That by 4 over 4. So I end up with a v squared minus 9 times 4 is 36. So I'm going to rewrite this in standard form. Keep, change, flip. Just like that. Okay, now I can factor this. That's a perfect square not a perfect square trinomial, but a difference of squares. Let's go ahead and make it into one long fraction. So I have a 4v, v plus 6, 2 times v plus 6, v minus 6. We can start simplifying. We have a 1 and a 2. V plus 6 is canceled out. So I end up with a v over v minus 6. Oh, I forgot a 2 at the top. Okay, good job. Next, let's write this horizontally. 2a over 9b minus b over 2a divided by a over 3b squared plus 1 over 2b. Okay, let's find the common denominator of these two fractions. So we have a 2 times 9 times a times b. Okay, what's missing from that 9b denominator to 2 times 9 times a times b is going to be, it is going to be a 2. Oops. It's going to be a 2. And we have a 9. We need an a, so I'm going to multiply top and bottom by 2a. Okay, so 2 times 2 is 4. I'm going to write that in a different color. Is 4, and then a squared. If I compare the second fraction denominator with the common denominator, I have a 9 missing and a b missing. So I'm going to multiply top and bottom by 9b. So I end up with a minus 9b squared. Divide by. Okay, let's go ahead and find the common denominator of this. So we have a 2 times 3 times b to the second. The greatest number of times that b appears is twice. Okay, is that an a? Yeah. And then so let's go ahead and find what's missing. It's going to be a 2 times 2. So I have a 2a compared to the second fraction, 2b, and that denominator, what's missing is a 2 and a b. No, it's not. It is a 3 and a b. We have a 2, we need a 3, we need another b. So b, okay, plus 3b. Let's go ahead and keep change flip. 4a squared minus 9b squared over, wait a second. Why did I rewrite this as, I have no idea, guys. See? 2 times 9 times a times b. No! No, that wasn't the common denominator. I'm just kidding. I'm sorry. Let's go. Yeah, that was completely separate. Okay, so keep change flip. So that is 18 AB times, that's going to be 2 times 3 is 6B squared over 2A plus 3B. Okay, are you having fun? Now, let's take a look. Now I can make it into one long fraction. But do you see this right here? That's a perfect square trinomial, guys. What are the two factors that are exactly the same that make up 4a squared? 2a times 2a. 9b squared, 3b times 3b. And isn't that what you see here? Ah, remember I said think like a teacher. Okay, so I'm going to go ahead and factor that. We have a 2a plus 3b and a 2a minus 3b, 18ab, put it under one big one, times 6b squared, parentheses 2a plus 3b. Now let's see if we can simplify anything. Okay, yes, 2a, 3b, we can simplify that. 6 and 18, 1, 3. And then the b's, that cancels out, and a b. So let's go ahead and collect all the things that we did not cancel out, the factors. So I have a b in the numerator, 2a minus 3b. And I have a 3. And don't forget this a. That's my final answer. It's very colorful. Good job, guys. Okay, next. Let's write that horizontally. So x squared over 1. Notice I always put any kind of, things that don't have a fraction over 1. Because that's exactly what we're going to do. Divided by x plus 1 squared over 4x. There is the second, after division, that expression is already combined. So we just need to combine the first. X is its GCF. So I'm going to multiply that by x, that by x. So I get x cubed plus 1. Keep, change, flip for x over x plus 1 squared. Oh goodness, I have a sum of cubes again. Okay. So let's go ahead and this is a sum of cubes, and I tried not to put any sum of cubes on here. Okay, like right here. No, that's not a good color. This is sum of cubes. The formula for the sum of cubes is x plus 1. Okay, you cube root the first term, you cube root the second term. So the cube root, x to the cube is made up of x times x times x. So that's x. And you cube root the last term. So 1 times 1 times 1 makes up 1. Okay. And then you square that first term. And it's a minus. And it's an AB. So you have to multiply the A and the B together. So it's 1 times x. And then B squared. So if we had x cubed plus 1, the a, so that would be a cubed plus b cubed. So the a plus b, and then a squared minus ab plus b squared. So when you identify a as being x and b as being 1, so that would be x plus 1. And x squared minus x plus 1, okay, over x times 4x, x plus 1 squared, okay. Now when you combine it into one long fraction, you have 4x, x plus 1, x squared minus x plus 1, over x times x plus 1 squared. Let's go ahead and simplify. Take that x out, take that, make it 1, and this simplifies as x plus 1. Okay? So your final answer is going to be 4 times x squared minus x plus 1 over x plus 1. And there you go. I think I did all the problems. Good job, good job. Okay, bye guys.